force triangle method. It is also known as triangle law of forces, and it is generally used for two number of forces. Now if we look at to the statement of that force triangle method, so that is, if two forces acting simultaneously on a particle be represented in magnitude and direction by the two sides of a triangle taken in order their resultant may be represented in magnitude and direction by the third side of the triangle, and that is taken in opposite order. So when we take a two forces, those are acting simultaneously on a particle, so we represent that two forces with two sides of a triangle, and the other side, that is generally known as a closing side, that represents a resultant of that two forces in terms of magnitude as well as direction. So this method is generally known as one type of graphical method. Now in this method, if we draw two forces, that F1 and F2, so if we take a force F1 and F2 in particular direction, and if you want to find out a resultant of that, so for that forces we have to plot a proper graphical representation using a proper scale with respect to the given force value or the force magnitude F1 and F2 in order. That means if we take a force F1 in this particular direction with its proper magnitude with taken proper scale, so we require to take a scale first, and according to that scale we have to draw graphically and in an order. So F1 is this, again maintaining the direction of that force F2 as well as according to the given scale, and in the opposite order if we join that with another side of that triangle, so that side is going to represent a resultant of that two forces. So in this, whatever the measurement available of this third side, that would be the resultant R value. So this method is probably used in an experimental way. So if we have a value of f1 and f2 that is measured in an experiment, so if you plot this graphical representation on the paper with a proper scale, so we can get a resultant R value using a graph. So this is all about a force triangle method.